Chapter 4: Einstein and the General Theory of Relativity. Albert Einstein is famous not only for his groundbreaking theories, but also for the unique way he developed them. One of his most powerful tools was the thought experiment. A thought experiment is a way of testing an idea in your mind without doing a real experiment in a laboratory. Albert used thought experiments a lot in his work. He would imagine different situations and try to predict what would happen based on his theories. He would question assumptions, challenge ideas, and look at things from new perspectives. This was a key part of his creative process. One of the most famous thought experiments is the falling elevator experiment, which played a crucial role in developing the general theory of relativity. Albert imagined a person inside an elevator, which is falling freely in a gravitational field. According to the principles of physics, the person would not feel their own weight. They would feel as if they were floating in space without gravity. This led Albert to a radical conclusion. Gravity is not a force, but a curvature of space-time caused by mass and energy. This idea became the foundation of the general theory of relativity. This theory is an extension of the special theory of relativity, which Albert had developed earlier. The special theory deals with situations where there is no gravity. The general theory includes gravity, making it applicable to a wider range of situations. The general theory of relativity was a major achievement in physics. It provided a new understanding of gravity, which is one of the fundamental forces of nature. It predicted many strange and fascinating phenomena, such as black holes and gravitational waves. It also expanded our understanding of the universe, leading to the idea of the Big Bang. Albert's thought experiments were not just mental games. They were a serious method of scientific investigation. They allowed him to explore new ideas, test hypotheses, and make predictions. They showed the power of human imagination and creativity in the quest for knowledge and understanding. In the next part, we will learn more about the general theory of relativity and its impact on science and society. We will see how Albert's ideas were tested and confirmed, and how they continue to inspire scientists and thinkers around the world. One of the most exciting moments in Albert Einstein's career came in 1919, when his general theory of relativity was put to a real-world test. This test was based on one of Albert's predictions about how light behaves in a gravitational field. According to the general theory of relativity, gravity is not a force, but a curvature of space-time caused by mass and energy. This means that when light passes near a massive object, it should follow a curved path, not a straight line. This effect is known as gravitational lensing. Albert predicted that we could observe this effect during a solar eclipse. When the moon covers the sun, the stars near the sun become visible. Their light passes close to the sun on its way to Earth. If Albert's theory was correct, the light should be bent by the sun's gravity, causing the stars to appear slightly out of position. In 1919, a British astronomer named Arthur Eddington organized an expedition to observe a solar eclipse and test Albert's prediction. Eddington traveled to the island of Principe, off the west coast of Africa, where the eclipse would be visible. He took photographs of the stars near the sun during the eclipse and compared their positions with their normal positions. When Eddington analyzed the photographs, he found that the stars were indeed out of position, just as Albert had predicted. The deviation was small, but clear. This was a dramatic confirmation of the general theory of relativity. It was a triumph for Albert and a turning point in the history of physics. News of Eddington's observations spread around the world, making Albert an international celebrity. Newspapers hailed him as a genius, a new Newton. People were fascinated by his theory, even though it was difficult to understand. They were captivated by the idea that a simple equation, E equals mc caret 2, could explain the workings of the universe. In the next part, we will learn about Albert's life after this momentous event. We will see how he handled his new fame and how he continued to contribute to science and society. We will also learn about his personal life, his beliefs, and his values. The general theory of relativity was one of Albert Einstein's most significant contributions to science. It revolutionized our understanding of the universe and has had a profound impact on many areas of physics and astronomy. Before the general theory of relativity, scientists used Newton's laws of motion and gravity to describe the universe. These laws are very accurate for many situations, but they do not work well for objects that are very massive or very fast. The general theory of relativity provides a more complete and accurate description of the universe, especially for these extreme situations. One of the most important results of the general theory of relativity is the concept of black holes. A black hole is a region of space-time where gravity is so strong that nothing can escape, not even light. Black holes were first predicted by the general theory of relativity, and they have been observed by astronomers many times since then. They are one of the most mysterious and fascinating phenomena in the universe. Another important result of the general theory of relativity is the concept of gravitational waves. Gravitational waves are ripples in space-time caused by the acceleration of massive objects. They were first detected in 2015, 100 years after Albert predicted them. This discovery was a major achievement in physics, and it opened a new way of observing the universe. The general theory of relativity also changed our understanding of the universe as a whole. It led to the idea of the Big Bang, which says that the universe began as a hot, dense state about 13.8 billion years ago. This idea has been confirmed by many observations and is now the standard model of cosmology. In addition to these scientific impacts, the general theory of relativity has had a cultural impact. It has changed the way we think about space and time, matter and energy, reality and perception. It has inspired artists, writers, philosophers, and many others. It has become a symbol of human curiosity and creativity, a testament to our ability to uncover the secrets of the universe. In the next chapter, we will learn about Albert's life after the confirmation of the general theory of relativity. We will see how he dealt with his fame, how he pursued his scientific work, and how he became a voice for peace and human rights.